On Tuesday, March 5th, 2019, at around 8 p.m. US Eastern Time, I was at a bar. The temperature hadn't risen above freezing that entire day, so it was a warm and welcome respite. I was sitting at the end, right in front of a TV, because I was there to watch a college basketball game. That night, the VCU Rams were playing one of their biggest rivals, the George Mason Patriots. And the game started off pretty simple. VCU took a 28-21 lead, but in the second half, something pretty remarkable happened. VCU outscored their opponents 43-15 for a final score of 71-36, almost doubling up their opponents. But I didn't get to see any of that because I was staring at graphs, because I was on call. And I watched some graphs plummet, and I watched other graphs surge, but they all told me the same thing. Our users could not access their recent logs. We'd entirely stopped indexing. And this has been a thing we'd been dealing with for weeks, if not months, and we'd almost started to ignore it because there was nothing left for us to do. We felt like we'd tried everything. We were starting to feel hopeless. But who are we? My name's Alex Hidalgo.
And I'm Alex Lee. Together, we lead the observability SRE team at Squarespace. And this talk is a case study on how we took our centralized logging infrastructure, depended on by the entire Squarespace engineering organization, from being reliable approximately 85% of the time to a trusted and documented 99.9%. Together, we want to walk you through some of the SRE best practices that we applied to our situation to achieve this improvement. Now, in speaking about reliability, it's important to keep in mind that none of what we're facing is new. Industries far older than our own have been grappling with reliability for far longer than us as well. Take the alarm fatigue that Alex was suffering from earlier. Similar fatigue has been observed in fields like healthcare, where in hospitals, monitoring devices often fire alarms for such small issues that they lose their intended sense of urgency. On mining and construction work sites, vehicles are always backing up, such that their beeping just becomes meaningless background noise. Even in the nuclear power industry, they're known to ignore alarms that they shouldn't because there are just too many. As a society, we've known about this for millennia. Like the boy who cried wolf, a liar will not be believed even when they speak the truth.
And when it comes to service reliability, this stuff isn't new either, right? This has also been studied by many people for a long time now. So this is not an exhaustive list, but here are some of the things that we did and some of the things that we want to speak about today. You need to alert on what actually matters. Developing SLIs and SLOs can be incredibly helpful. You need to increase your observability so you can understand what's actually going on. You can improve your tooling and automation. You can trust proven paradigms from outside of tech, but you can also conduct retrospectives and learn from your own past as well.
But first, let's start with some context, just to give you a backdrop as to what we're talking about. The story begins really in the spring of 2015, when we introduced ELK at Squarespace. What is ELK? Well, ELK, or the Elastic Stack, as it's also known, is an open source log aggregation tool that I'm sure many of you here at SREcon are familiar with. Why did we choose to use it? Well, it was in order to scale our observability platforms with our growing microservice-oriented infrastructure. Our previous paid logging solution was too restrictive in the data volume it could handle, so we turned to managing our own stack to meet our scaling requirements. And soon after, ELK quickly became the highest trafficked service in all of Squarespace's infrastructure. Just to give you a little bit more context, let's run through a pretty quick architecture overview. So we start with the log shippers. These are VMs, they're Kubernetes pods, even bare metal machines shipping logs, and they send it to Kafka. Kafka is a basic message queue. It functions as a buffer for us as we're processing the logs. From Kafka, the logs get picked up by Logstash. Logstash just does some basic parsing. It grabs keys and values, forms it into more well-structured data, and then ships these logs to Elasticsearch, where they get stored for our retention policy of approximately 30 days for most logs. And it's from Elasticsearch that users will interact with Kibana that then queries Elasticsearch to grab the data that they need. ELK, or ELK, gets its name primarily from the three components at the end there, Elasticsearch, Logstash, and Kibana. And this served us well for a time. But there's a reality in providing a platform that generally works well for people. They start to use it a lot. We chose Elk in order to accommodate our scaling infrastructure, and well, the infrastructure scaled. With new kinds of load, we started encountering new and unfamiliar failure modes within Elk. Fast forward a few years, August 2018, when things got especially bad. As described by Alex at the start of the talk, this is when we started having that issue every day at UTC midnight, or 8 p.m. in New York time. We experienced periods of instability that would last anywhere from 5 minutes to a few hours. And during these outages, users' logs were either unavailable or completely lost. And this went on for months. Every time we thought that we had solved it, problems would just pop right back up again a week later. The organization was losing faith in our systems, and the team was burning out. It was a really, really rough time. And this is where our story really begins. This is where we started the long road of recovery. And what we found to be one of the crucial first steps was to have a correct framing of the problem at hand. And that's our first principle, to alert on what matters and to put your users first. Let me first show you all the ways that we used to be informed when Elk was having a problem. It's a lot. First, we would check, are all the Logstash processes running? Is the Logstash to Kafka connection healthy? Is Logstash to Elasticsearch connection healthy? Is Logstash to Elasticsearch throughput at an acceptable rate? Is the Elasticsearch process running? Is Elasticsearch experiencing a cluster block error? So on and so forth. I should also mention that many of these were host-based alerts, meaning if a single issue were introduced to a configuration file or what have you, we didn't receive just one Logstash process down alert, we received 50 of them. Now, it didn't start this way, right? But as Elk experienced incidents over the months and the years, we just kept adding to this list to cover every new failure mode that we encountered. I'm sure anyone who's maintained a complex system can relate to that, but it just doesn't work. And here's why. First of all, it was noisy. The spam was burning us out. We were battling PagerDuty just as much as we were battling the incidents themselves. And this was quickly leading to alert fatigue for the team. At Squarespace, we're about empowering engineers to do their best work, but burned out engineers just can't do that. Secondly, these alerts only covered known unknowns. They were too white box. They only covered scenarios that we expected or had already quote-unquote root caused. Therefore, there were often still incidents where our users, being other Squarespace engineers, were the first to report them to us because our automated systems were entirely unaware. And finally, these alerts were not user-focused. They were ultimately not reflective of the end user's experience. In fact, it was easy to imagine scenarios, and these happened, in which one or more of these alerts would be firing, and yet the system as a whole was operating completely fine from the user's perspective. Just like known unknowns resulted in a lot of false negative alerts, a lack of user-focused alerts resulted in many false positive alerts for us as well, which further contributed to engineer burnout. To address these, we took a step back and thought, what is it that our users really care about? And could we alert on only that? And what it was that our users cared about was surprisingly easy to determine, simply based on how they complained in Slack when there was an incident. My logs are delayed. Is Elk having issues? They didn't care about the internals of Elk, everything that you're seeing here on the screen. What they cared about was how long it took from when they shipped their logs to when they could query their logs. The end-to-end latency of this pipeline. And so with the metrics available to us, we were able to build an approximation of this figure based off of the consumer lag in Kafka divided by the rate at which Logstash was writing to Elasticsearch. It wasn't truly a black box monitoring solution, but it was a start for us. So we started measuring this metric and found that our average latency during normal operations hovered around 2 to 4 seconds. And during incidents, we could see that latency spike into the minutes range, and it was then that we would be alerted. We could now know with greater confidence exactly what level of service our users could expect from Elk at any given time. And this metric became our first SLI, or service level indicator, as Alex will talk more about in a bit. Now, even though ELK was still regularly experiencing incidents, having this metric dramatically improved our ability to transparently communicate with our users and maintain a positive relationship with them. Now when they ask this question of, is ELK having any issues? We could give them a clear answer as to the level of service that they could expect at that moment. Right? Yes, your logs are delayed by about 5 minutes. And also to be clear, we still had insight into all of the metrics that our old alerts were based off of. However, once we made this change, we began being alerted about ELK when and only when there were real user-impacting problems, reducing the risk of both false positives and false negatives. Now, Alex will talk a little bit more about how we took this SLI and made it even more useful to us.
So the second principle that we want to talk about is how to develop meaningful SLOs. So I believe there are 3 primary truths about any service. 1, reliability is its most important feature. And I don't mean availability here. I mean, is your service doing what your users need it to do? And because of that fact, your users determine if you're reliable or not. I don't care if you have 0 errors in your logs or your metrics say everything's perfect or 50 out of 50 cube pods are running. If your service isn't doing what your users need it to do, it's not being reliable. And finally, nothing is perfect. You can't hit 100%, so don't aim for it. Pick a more reasonable target. So the best way to accomplish this, in my opinion, is something that I've dubbed the reliability stack. And at the bottom, we have SLIs, or service level indicators. And a service level indicator is just a metric that tells you how is your service doing from your user's perspective, right? The best way for this to work is it's often a ratio of good events over bad events, because that gives you a percentage, which we'll get more into in a few. And again, just to drill this home, it needs to be measuring things from your user perspective. Black box is almost always better than white box here. Now, SLIs inform SLOs, or service level objectives. And if you remember just a second ago, we mentioned that the best kind of SLI generates good events and bad events, so you can have a ratio of good events over total events, and that gives you a percentage. An SLO is basically just the target for what you want that percentage to be. This is also where you can do things like introduce thresholds, so you can say things like, the 98th percentile of all of our incoming web requests must complete within 200 milliseconds, but maybe the 99th percentile doesn't have to complete until 400 milliseconds, et cetera, et cetera. But the primary thing that an SLO lets you do is pick a reasonable target, because nothing is reliable 100% of the time. That's a fool's errand. And now finally, at the top of the stack, we have error budgets. So an error budget is just a way of telling you how your SLO has performed over time, right? It's not very interesting to say, are we meeting SLO now? Are we meeting SLO now? Are we meeting SLO now? An error budget lets you track how this works over the course of a day, or a week, or a month, or a quarter, or even a whole year. But one of the other most important features of error budgets is they just let you describe things in more human terms, right? 99.9%, that doesn't really mean stuff to most people unless you live in this world and have memorized exactly what all these 9s and sometimes 8s or occasional 5s actually mean. An error budget lets you say something like 99.9% reliable means we're also saying we might have 43 bad minutes every 30 days. And error budgets are awesome, right? They're a guide to help you make all sorts of decisions. Now, it's much more complex than that, but this talk isn't all about error budgets. But the basic principle is something along the lines of, do you still have error budget remaining? Then do what you want. Ship more features, perform chaos engineering, experiments. But if you've ran out of error budget, halt everything, focus on reliability. And so let's go back to that night at the bar on the cold winter day. UTC midnight struck again. And again, all the new shards were introduced, right? This is when we rolled over indices, and this is when everything broke. And by 8:36 p.m. that evening, we ran out of error budget. And you might be surprised to learn, we developed and only started measuring our SLO about 27 hours before, at 4:30 in the afternoon the previous day. But the point is, we kind of knew that we had problems, and we started tracking them correctly. We didn't expect to run out that quickly. And this was our original SLO. Reads a log line will be processed on average within 5 minutes, 99% of the time. And let me tell you, that's not very ambitious, right? let's do the math here. If you have a 99% target, that means you're saying you're gonna be down 1% of the time, and over a 30-day period, that means 7 hours, 18 minutes, and 17 seconds of bad time. We ran through that in 27 hours. Even so, this first non-ambitious SLO left our most senior engineers and our stakeholders absolutely stoked, because that's how bad we'd been. So with no remaining error budget, we gave ourselves permission to go all in. Like, we dropped project work and everyone said, we need to fix this.
So with that permission, the first thing that we did was to increase our observability, because you need to know what's happening inside of your system to fix it. Makes sense? Now, we had some existing observability within Elk. I mean, we hadn't gone 3 years completely blind as to what was going on inside of it, but most of it was host-level monitoring. We were tracking things like, are the processes up? How is the load on the system? How's the disk usage? How's memory? Elasticsearch also has a pretty good API that we got comfortable working with, but we would query it ad hoc, and it would give us logs or text output, and so there was no aggregating over that. And so we really needed better insight into what the applications themselves were doing and automatedly track that information over time. And so we went component by component and increased our observability across the board, as represented by this magnifying glass icon. So starting with Kafka. First thing we did was we built a service that tracked the rate of incoming logs per application. Previously, it was just a big flood of logs, and once we built this service, we could see which of the external applications were generating the most logs and contributing the most to that incoming flood. Then we turned our attention to Logstash, where we tagged every single one of our Logstash filters so that we could track them individually for rates of success and failure, as well as how long it took for them to process. And then we looked at Elasticsearch, where we installed some Prometheus exporters to get more application-level metrics and understand what Elasticsearch itself was doing. We built another service that tracked the movement of shards within Elasticsearch, and we also, at times, enabled JMX to get insight into the JVM as incidents were ongoing. And so after we had made all those improvements and gotten all these new metrics and insight, we made revisions to our triage dashboard. Which I know, dashboards, tech debt, a little controversial, but still, despite this still being a little cluttered, it was far more useful to us than it used to be, and saved our butts a lot during many incidents that came afterwards. Now, after increasing our observability, the next thing to do was to improve the environment as a whole, specifically with regards to tooling and automation. We looked at the components that generated the most toil and required the most manual interactions. And one of the first places was, once again, Logstash. For various reasons, certain log types would start spamming Elk with lots of noise, which would impact all users' experience of Elk. And we asked, how could we shield Elasticsearch from this behavior and not waste disk space on useless log messages? And so what we built within Logstash was the ability to black hole logs when they would become too spammy. And so this was just an effective solution to cut down on that noise and shield Elasticsearch as we had wanted to. Then we looked at Elasticsearch again. I mentioned previously that it has a pretty solid API, and so we built a command line tool to interact with that API to run the most repeated commands that we would use during incidents. We also fixed a bunch of bugs with regards to index deletion for any indexes that lived longer than the 30 days they were supposed to. We wrote all sorts of scripts to even pre-create future indexes, which reduced the impact of that UTC midnight transition. And we wrote a query killer, which would automatically cut off any long-running queries that had been triggered by users and were impacting the entire system. And there's one final component in this whole diagram that I actually haven't spoken about yet, and that's the log shippers and the queryers, aka our users. I previously mentioned that services would sometimes spam us with logs. At times this was due to a DDoS attack on Squarespace, which would cause increased logging from some of our edge services. But other times this was just due to users increasing their logging verbosity in production. Debug, -VVVVV. We realized that we needed to educate our users to be good citizens of the platform. And so we wrote documentation on logging best practices, and we developed a Kibana 101 course to teach users how to most effectively query for their logs. So we went from having a system with little observability and tooling to having one with eyes and levers of control everywhere that they were needed. Now, at this point, there was still more work that we had planned to do, but we were feeling pretty good. We had made a lot of progress, and we were better equipped to handle all kinds of scenarios. However, these technical improvements alone wouldn't prove to be enough for the worst outage that we were about to face. Alongside of this work, we had also been practicing how we as a team responded during these times of crisis, which Alex will now share some more about.
So the fifth principle that we want to talk about today is to trust proven paradigms. So I actually think we're at a very exciting time. More than ever, I feel like the tech industry is hurtling towards a world where we stop inventing our own solutions and realize that a lot of this stuff has already been solved by other people, right? Like, because reliability isn't new. Like, engineers have been working on this for as long as they've been building bridges, and statistics is hundreds and hundreds of years old. First responders certainly have developed great ways to deal with stressful situations. And while I'd love to talk about all these, don't really have time for that. So I'd like to focus on one, and that was our adoption of the incident command system. So the incident command system is something that was formalized several decades ago by a bunch of fire chiefs in Arizona. It was due to the fact that they weren't able to they weren't able to put out forest fires at the rate that they believed they should be able to. And this especially became difficult when they had to work across county lines and across state lines, and many different agencies were involved. So they wanted to figure out how to better streamline their response, and they did this by bringing in a bunch of academics and saying, here's data, help us figure out what's wrong here. And the conclusion of the study basically says that there was 4 primary problems. One, there was a general lack of accountability, communications were poor, there was no established hierarchy, so no one really knew who was in charge of what and at when, and this led to too much freelancing, people just kind of making their own decisions and doing their own things. And the ICS is very complicated, but you can adopt a simple version of it for your software. So one of the primary things that the ICS helps you do is proper delegation of duties during an incident. The way this works is you have an incident commander. This is generally the first person that responds to a page. For some companies, it may be a special rotation that you escalate to. And when an incident commander comes on the scene, they wear all the hats. They are responsible for everything. But a major component of this, again, is being able to delegate. So what you can do is have something like the incident commander can say, you are now the operations lead. Please make all actual production changes. And maybe this is a very large incident, so maybe you also need a communications lead, someone to update the status page or communicate to other teams how things are going and what the ETA is. And you might even have someone like a planning lead, right? This might be someone who's keeping the incident state document up to date, or maybe they're proactively finding bugs. If this is a very long-running incident, this person might even be involved with getting coffee for the responding engineers or ordering pizza to make sure everyone's fed. But you can drill down even further, right? So let's look at the operations lead. The operations lead themselves may say, hey, I need you to be the databases operations lead, and you to be the networking operations lead, and you to be the systems operations lead. But the point is, all of this still flows up all the way back to the incident commander. Now, the other important thing that the ICS helps you do is ensure you have a proper system for handing off, because sometimes incidents run very long. So an example of how this works, you have your incident commander, and they're in charge of certain things, and they know who all their leads are, and the second incident commander shows up, the first one steps away, the second takes over, and this allows the first one to rest or finally go to bed. And we needed this system, and I'm glad we started practicing it, because we were about to experience our worst outage yet. So on Tuesday, March 21st, again, at UTC midnight, 8 p.m. New York time, everything broke, and this time it broke the worst it ever had. So you don't have to pay attention to every single thing I'm about to say, but let me very quickly go through what a timeline of a 37-hour incident looks like. So at UTC midnight, the consumer lag started increasing again due to the rolling over to the new indices and the new shards being brought in, and then at 8:05, a node with way too many shards was identified, so at 8:10, the on-call engineer ran a command to try to spread these shards out better so we have a better distribution, and then for 4 hours, basically did nothing. And at 30 minutes after midnight, the on-call engineer disengaged because all he could think to do was I just gotta wait for this. Except the problem is at 1 a.m. the pre-create indices scripts ran, which created a bunch of new shards, and even though they weren't being used yet, they were shuffled around from 1 until 6:30 in the morning, so indexing continued to slump, and we couldn't process logs. And then finally at 8:05, the on-call engineer set allocation of primaries, and that means we don't care about the replicas anymore, so there's only half the shards that the cluster has to keep track of, and then apparently stuck node was identified and restarted, and then the translog heap was changed from half a gig to 2 gig, and at 10 a.m., all the log sessions were restarted, and at 1:02 p.m., there was a new log that was found that we ended up black holing, and then finally at 2:18 the following day, the incident commander handed off and was able to go to bed. So to keep going, well, we probably tried changing something about the indexers, and then maybe we tried to move more shards around for balance, and I think at one point someone said something like, let's try restarting the load balancers. The important part is we performed handoff after handoff after handoff after handoff until finally at 9:23, 37 hours after this incident started, we were finally caught up and we were able to declare an all clear. Every member of our team acted as an incident commander at some point in time. But one of the most interesting parts about all this is that when your back is against the wall and things are really bad and this sucked, right? Sometimes your perspective changes. And so the next part of our story is the next day, Sunday, March 24th. It was 60 degrees out that day, so I went for a walk. And I was trying to not think about everything that we've been dealing with for the last month, but like, couldn't get it off my mind. And like, I kept thinking, and clearly the problem was shard related, because every time we were moving shards, things got worse, and every time new shards were introduced, things got worse. And it was always these new shards, and wait, maybe it wasn't the new shards. Maybe it was the total number of shards. So I got home from my walk and I Googled something along the lines of, how many shards should I have in my Elasticsearch cluster? And what would you know but a blog post on Elastic's official site titled, how many shards should I have in my Elasticsearch cluster came up. And there's an important quote from this. A node with a 30 gig heap should therefore have a maximum of 600 shards, but the further below this limit you can keep it, the better. And let's do some quick math, everybody. 600 is much less than 2,200, which is how many shards we had per node in our cluster. So we proceeded with what we ended up dubbing the unshardening. It was not easy for us to go back and have old indices have fewer shards, but we realized it was easy to make sure new indices had the proper number of shards. We were allocating 20 shards per index, even for indexes that only had on the order of a few hundred K of logs per day. So it took a long time, but as you can see in this graph, every single day our total shard count dropped, and every single day the impact of our incidents at UTC midnight was minimized more and more and more.
So until finally, after a few weeks of stability, we now moved into this final SRE best practice, which is to conduct meaningful postmortems and to learn from your own past. So earlier this year at Monotorama 2019, Nida Farouk shared this great talk on postmortems. She described them stating, a postmortem is an argument for change. And a good bit of this next section is just adapted from that talk. So what are the key components of a postmortem? First is data collection. Within data collection, we can start with the impact assessment, which is user-focused. We want to understand what was the impact from the user's perspective. How did they experience the incident? How did your SLO or SLA get impacted by the incident? How was the business's bottom line affected? Next, there's also the timeline of events, where you can pay particularly close attention to when the incident started, when it was detected, whether by humans or by systems, when it was engaged by engineers, and when it was mitigated, again, from the user's perspective. Not from our side of like, I clicked the button, everything should be good now, but we want to wait for the users to say that it's good on their end. And finally, within data collection, there's contributing factors, which we make a distinction from root cause analysis because we generally believe that to be a bit of a logical fallacy. There are all sorts of great resources that discuss emergent behaviors in complex systems, and that's why we've generally found singular root cause analysis to be a bit misleading when talking about incidents. Instead, consider all of the factors that contributed to the start and the prolonging of the incident. After data collection, we move into the lessons learned phase. And here are just a few of the questions that we like to ask when thinking about what lessons we learned. First, what went well? This is a time that we can give shout outs to other engineers, maybe certain systems that behaved better than we expected. And it's just a time to celebrate what good things happened during an incident. But inversely, we also ask what went poorly. We want to know and be honest about the things that didn't go great. And it's in this section that we're particularly mindful to not throw blame around. The last question that we love to ask is, where did we get lucky? Because luck is such a real part of incidents, as I'm sure many have experienced. And so we want to call that out when we move into the final stage of postmortem, which is repair items. Now, in brainstorming repair items, there are generally two types or two buckets that they can fall into. The first being incident response. How can we improve our incident response? This is a time that you can do an analysis of your timeline and see how you might shorten the time to detect, the time to engage, and the time to mitigate to reduce the overall duration of time that the incident lasted, to reduce the impact to your users. The second bucket here are systemic changes that are generally preventative or mitigative in nature. This is a time to ask, why do we even X? Why is the system architected this way? Should we add this new thing? Should we take away this other thing? During this brainstorming of repair items, diversity of backgrounds and expertise is key. You want to invite representatives from every stakeholding group. Engineers who built the system, customer operations experts who interact with your customers during the outage, and even product owners. They'll all have a unique insight into how you can improve the overall reliability of your service. And so it was on April 23rd, 2019, about a month after that 37-hour incident, that we began to write our postmortem for Elk. Now, because this had taken place over the course of a few months, we titled this postmortem the 2019 State of Elk. And we opened with the impact that over a period of several months, Squarespace engineers could not reliably depend on Elk. Yeah, it's not great. It's not a very positive statement. But it was important for us to begin with this transparency, because immediately following this was 9 pages detailing what happened, what we did to fix it, what we had learned, and what we would do to keep improving our reliability. And in fact, it was in writing this postmortem that we were inspired to share this story with you all here today. And about a week later, we shared this postmortem report with the entire engineering org. And that was the end. Or is it?
So there's a 7th principle that we didn't outline at the beginning that I think might be the most important of all, and that's you need to iterate over everything. Because you can make good be great, right? You can always improve. You can always make things better. And so this because progress is always incremental. It always happens in steps. So I want to share with you a few things that we continue to do for a little while after this incident. And that's everything, right? We didn't change our approach. We continued to make our monitoring better and have better observability and better automation and tooling, right? But I think maybe more interesting is to talk about the things that we still do today, which is also everything, right? These are core principles for how to keep services reliable. They're not just ways to respond to a single bad long-running incident. But I think maybe the most important one that I'm able to show as an example here today happened on Friday, May 10th. At about 3:30 in the afternoon, we updated our SLO target. So if you might remember, our old SLO read, a log line will be processed on average within 5 minutes 99% of the time, and our new SLO read on average within 2 minutes 99.9% of the time. And we've been mostly able to adhere to that ever since. And let me tell you, our stakeholders were absolutely stoked.
So just to recap and conclude, alert on what matters and put your users first. Develop meaningful SLOs, and don't try to be perfect because it's just not possible. Increase your observability because you need to know what's happening in order to fix it. Improve your environment. Tooling and automation are your friends. And trust proven paradigms. We can learn from those who have come before us. Conduct meaningful postmortems because you can learn from yourselves too. And finally, iterate over everything, again and again and again.
But there's one more thing I want to say before we finish. And that's, it's often darkest before the dawn. If you find yourself in a similar situation to the one that we did, where you feel hopeless and you feel helpless, while you're digging yourself out, just know you're going to be amazing. Thank you.
All right, we have about 3 or 4 minutes for questions. If you have a question, please, let's see, actually, I don't have a mic up there, so raise your hand and I'll come find you. Over there in the back.
Hoi, JC.
Hoi, good day. Alex is. To Alex is, right?
Yeah.
You talked about how you iterate over everything again and again and again because you can make the good be great. How do you decide when to stop polishing the diamond?
I think that is where SLOs and error budgets come in, right? Like your target should only be as good as your users need it to be. Our original target at 99% for our log processing within 5 minutes, for example, that may have made our stakeholders happy because we were at about 85% following that metric at first. But we wanted to improve on that because our users still weren't getting out of our service exactly what they needed. So we upped it to 99.9. And we may up that even more at some point, but so far, even when we've had other incidents, users seem okay with the current state of things. So yeah, you want to iterate over everything over and over again, but I think the limits that you place are, is this good enough for our users? And now can we focus on something else, right?
How do you decide that?
So I can add in practice, actually just a couple months ago, once we met this SLO of 99.9 and we maintained that for a few months, but then a couple months ago we started having some more regular periods of downtime again. And it wasn't necessarily downtime, we were just exceeding that 2 minutes more often than the error budget that we'd given ourselves. And so once again, for a sprint's worth, we canceled other project work and said, everyone, we're gonna focus on elk reliability until we regained that error budget and then got back on the project work.
Thank you. We have another question from Stefan.
Hello. You mentioned improving on observability and then having more monitoring and more automation. So you have, from what it looks like, a very big set of producers effectively feeding onto Kafka. Do you have any kind of kill switch or like end of the world approach to logs, priorities? Like, what do you do about it?
Yeah, those are some of the things that we explored during this time, but a few of those basically didn't prove to be successful or very effective, so they weren't included in the talk. But yeah, those are things that we explored. And you notice our SLO was actually strictly around latency. We could consider having another SLO around durability and making guarantees that logs get through. Technically, we don't promise that right now. And so there have been incidents where it was particularly bad and we needed real-time logs now. And so we would just clear the whole Kafka queue. And unfortunately, we lost those historical logs, but we were able to restore real-time logs at that moment.
But that's just another example of iterating over everything, right? We may not currently have an SLO for durability, but that's something we want to have.
Hello, thank you for your presentation. I'm kind of thinking of the whole incident management and team and the role distribution. How big of a team are we talking about? When during your 37-hour outage, how many people were, let's say, on call at the time? How many people were handling this?
Can I ask how many people you think it was?
I think 4 or 5 maybe.
Oh, yeah, that's not far off. We were 6 people. Yeah.
Well, we're 2 people.
So during that time, we would actually, we tried to even have no more than 2 or 3 working on it at the time because we needed the other people to be resting and disengaging.
But we did have 2 people at all times. And shout out Hanan, who was eating coffee ice cream at 6 o'clock in the morning at one point.
Okay, we run out of time, and please thank Alex and Alex.